Hi, I'm Craig Ecclestone. I'm the product specialist here at Ava, and I'm just going to do a very quick experiment showing what the temperature basically is of ice water, and then I'm going to have a little bit of a play on that later on in the activity. So what I have here is I have a temperature sensor. It's a wireless temperature sensor that will be able to connect up to my device. I've got a desktop here, but it could be any type of device that's running our software and has Bluetooth technology. So to connect up to it, I just press the button, and through the miracle of wireless technology, and by connecting it up through the software, I connect. I did this previously, so I'm going to start a new experiment here to get it on there. Save data, no. And so what I'm going to do is I'm just simply going to click on the sensor data here. It should see that I have a temperature sensor connected, which it does. It's got plenty of power. And what I'm going to do is just simply click on the graph here, and it's going to plot temperature against time. And so I'm going to just simply record the temperature of this ice bath and see how low it goes, and obviously make a prediction of, it's going to go to 5 degrees, 4 degrees, what is it? My hope is it gets somewhere probably close to 0 degrees, but I don't think it's going to go below 0. So I'm going to take the water here, and I'm going to fill it up like so, and then take my temperature sensor. I'll hit start right now. All right, and there I'm collecting data, and I'm going to put it in there. Let's see what happens. So I've got it there. Okay, just rest it on there. I kind of want to make sure I'm right in the middle. And you can see it's going down quite quickly. It's responding very fast. We're right here. And we're just almost down to 0. We're pretty darn close to 0. Afterwards, I'll bring up the coordinates and see how close we are. But that's about as close to 0 without being spot on 0. And I almost say it's almost right on 0. And so the question is can I get it to go below 0? And well, I guess that would be rather difficult, because if it was below 0, it would all be ice. So it's unlikely that I can do that unless I change the solution. And to do that, I've got here some sea salt. And so all I'm going to do is take the sea salt here, open it up, and I'm going to be rather generous with it. I'm going to pour a whole fair bit in there. All right, and initially, not much is happening. All right, well, I could be patient and just wait and see if anything happens over time, but time is of the essence, and I don't want to waste a lot of your time, so I'm just simply going to do this, and I'm going to just use probably might be bad technique, but I'm just going to use the temperature sensor. There's a little stir there, and I think what you can see quite dramatically is that there's a significant drop in temperature. All right, and how low it goes, who knows, but that's it's now dropped almost to -2. Let's stir it around a little bit more, see how much lower we can get it to go. Stir it a little faster. Yeah, see if it can go down even further. Yeah, now it's below -2. Obviously, what's happening here, I can also tell the ice cubes seem to, as I'm stirring it, it seems like the ice cubes are melting. So it's almost the opposite of what you'd expect if it was pure water. Pure water was going below 0, you expect it to freeze. Here, as the temperature is dropping, it's actually not freezing at all. It's actually going much more to liquid. So, which is kind of interesting. I don't have all the answers as to why this is happening. I know that salt water, as everyone does, has a lower freezing point. But there's other things that are going on here. Well, the salt that I put into this solution, it wasn't below 0, it was above 0. So I've actually put probably more heat energy into it, yet that managed to drop the temperature below 0. So there's a lot of science that's going on here, and that's quite interesting. I think it would lead to lots of other interesting investigations. For example, do all ice cubes behave the same? Maybe I could use chunkier ice cubes or smaller crushed ice cubes. Do I get the same results? Do I get the same rate of cooling? How's that work? Obviously, I could change the type of salt I use, from table salt to rock salt to this type of salt. and see what effect that has as well. So, and maybe even just using some entirely different types of salts in determining the effect. So because you can get data so quickly with this, this could just be a 5-minute activity demonstration, but because you can get data so quickly, obviously using probe technology, it does allow for lots of opportunities to go and get more. So let's see, I'm just going to hit stop here. And the last thing I'm just going to do is I'm going to find out what the lowest temperature was that I reached. Was right about there. And with SparkView, you have a coordinates tool that I can click on, and I can drag that right to about there. And it went down, I got down to about minus 3.6 Celsius. And as I said, as it got cooler, we actually got more liquid, more of the ice had melted. All right, thank you very much.